G'day comrade subscribers. Finally, Tandy TRS-80 MC-10 together with the Matra Alice. I thought it might be interesting to have a comparison of these two cousins, really. I guess the obvious thing is that this has got a very chic red case, a boring white case on the Tandy. Obviously the other major difference is that we've got RF out on the MC-10, whereas we've got nice RGB output on the Alice. So that's quite nice. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, okay, that's interesting. The cassette. Oh no, that's the same. It's 5. For some reason I miscounted that. Otherwise, pretty much everything else is the same. We obviously don't have a channel selector switch on here. We use different sort of rubber feet on the Alice, but and of course we've got different keyboard. Although this is actually the actual PCB is the same PCB as this one. If you have a look, it'll actually say QWERTY for the key locations. So yeah, so QWERTY and AZERTY. So let's obviously we've had this one opened up, and I have actually made some modifications on it already. I've improved the keyboard cables, and I've put a modern switching regulator in there, and we're also using French components where possible as well. So for example, we've got a French component down here. Let's open up the MC-10, which I know has been done many times before. But let's do a side-by-side comparison. All right, looks like I'm the first one to open this, as the warranty sticker was still intact. Okay, and let's see if that comes out. Okay. That's right, very short cable. Let's just open that up. So unfortunately I can't swap the cables over, so as you might remember, I still have that keyboard issue I need to look at a bit further. The problem is there. The problem is I don't have any spare 8-pin wires like that available, so I can't just plug that straight into there. Not to worry. So as you can see, the main difference actually is that, yeah, we've got this RF shielding here, which is supposedly can cause a problem if you want to replace these RAM chips. So we don't have that kind of problem in the Matra. So let's just actually get, oh okay, it's soldered on, I'm going to have to desolder it. I think, oh yeah, that's right, this has got the bodge for the RAM as well. And obviously, yeah, the big difference is we've got the nice RGB output stage here compared to the RF modulator there. Alright, so let's get this out. Oh no, it's screwed down. I'll put this out here without blinding anyone. Maybe like that. One. I don't know if the Alice has got those. No, the Alice doesn't have any kind of, Alice board isn't screwed down. It is actually held down. We've got these things here that the Alice board slips into, like so, and then that kind of holds it in place without the extra screws required. So that's an interesting improvement. Alright, let's take these screws off. Okay. Yeah, we don't have these, where do they screw into there? Right, don't know where that screw came from. So I'm going to have to desolder. There, get rid of that. Oh, very shiny. Yeah, we had this on the Matra as well. I've already taken that off so that I could get at the underneath. So let me just remove that as well. Unfortunately, I don't think I'll be able to power this up, the MC-10, because I think getting composite video out is a bit convoluted. You can put in a replacement board. I think you reuse, there's a chip in here that generates the video that you can remove and use in a new board to generate composite, because apparently the chip can generate composite video as well, but you need the chip, the crystal, and a couple of other parts, a couple of transistors. So I won't be able to do that today, but let's continue. It's interesting, you've got like test points. Alright, so these are pretty easy to get off, which I can almost even just push them through with my finger. And I'll just remove the bottom shield, and then we'll be able to remove this. Right, here we go. So we've got the Alice on the right and the MC-10 on the left. Pretty much the same layout. Obviously some small differences. We've got the RGB out up here with a lot of transistors, whereas we've got the RF modulator up here with a dedicated chip actually, which is what makes it a little bit more difficult just to convert it to composite, because this chip will do composite, but it requires some additional circuitry. Same video processor chip right next door, so I guess you know, you could maybe create an RGB board for the MC-10. I like the capacitors on the Alice better. These like MLCC ones rather than these ceramic ones, and maybe polyester. So yeah, I'd definitely give points to the Alice for those. So we've got the power section here. So we've got, you know, because we've got AC in, so we've got the rectifier here and smoothing capacitor there, I guess, linear regulator there. So I'll swap this one out for a smoothing switching one, modern switching one. We've got two chips over here, so we've got U18 and U19, whereas on the Alice we've just got Z18. And actually Z18's got space for an 18-pin chip, but we've got a 14 pin chip in, which is interesting. So what chip was that? I can't really read it. You guys can probably see it on the screen. Whereas on the MC-10, we've got a pair of chips, 74 and a 76. A 74, is that a flip-flop? Some sort of flip-flop? Don't know. Okay, memory's the same. We've got 4K RAM on both. I think we've got I assume it's a buffer, 245. I think that's a buffer, isn't it? Buffer for the RAM, I guess. Then we've got the keyboard. So obviously I've replaced the original ones with some pins here just to improve the connectivity. And then we've got the pull-up resistors and the buffer there, and then the CPU. The CPU here is a French chip, and whereas on the MC-10 it's a Hitachi, so Japanese chip. We've got the PROM there. This one's a little bit different, but we'll get back to that one. But pretty much everything else is quite similar, although you will notice that on the Alice we've got the crystal right next to the CPU, whereas in the MC-10 it's part of the RF modulator. So yeah, so one of the things when you're apparently, because I haven't done it yet, because there is a PCB available, someone's very nicely done one, you basically need to rescue the crystal and the chip, put onto the new board with a couple of additional pieces. So yeah, that crystal's quite important, and I've obviously put it here because they don't have it in the modulator, because there is no modulator. yeah, no, coming back to this bodge wire stuff. So that apparently, if we have a closer look at it, so that apparently is because the memory map on this is 16 kilobyte blocks. So obviously we've got 4 kilobytes here. So the RAM block takes up 16K. So we've got this 4K is mirrored a few times, which apparently confuses BASIC. So the purpose of this bodge wire here is to gate some signal so that BASIC will report the correct amount of RAM. We don't have that on the Alice, so what I'm guessing is that this is the original design, and then obviously the Alice is a later design, so has properly incorporated. So what have we got here? So we've got a 74 LS 431. I can't read that. I need to go get my glasses. Even on, yeah, no, what? 74 LS 1 Z12. Whereas on the MC-10, I guess maybe it's sitting on top of of a 1. So yeah, so that's a major difference. But apparently that's in the schematic, so it was designed like that. And then obviously we've got the ROM as well. So interesting, we've got a smaller ROM. Because that's the thing, because it's 16K blocks, so the ROM can occupy 16K, but apparently it's only 8K. So here we've got a 24-pin ROM, whereas on the Alice we've got a 28-pin ROM. Just notice that. So it's 27. Sorry, let's have a look. Was it 2764? Is it? So that is an 8K ROM. Okay. Blah blah blah. Oh, what's that? Fujitsu. Anyway, so that's basically the differences. A lot of differences on the back as well. Obviously, we've got a lot more ground plane here. And we've got this bodge wire here to get ground. Okay, so we're taking ground. We're grounding a pin on that bodge wire stuff there, which we don't really need on here. And yeah, generally it seems that the MC-10 is horizontal and the Alice is vertical. So, for example, one of the problems we've got on the Alice is the keyboard. So we need to have a look at that. So I'm just saying. So okay, so on the MC-10, we've got the pull-up. We've got the keyboard connector to the pull-up resistors on this side of the board. Whereas on the Alice, it's on the bottom side of the board. Interesting. So there we go. So unfortunately, we can't power on the MC-10 because I can't get the video out at the moment. But I do want to compare the video, not the video, the keyboard scanning. So we know we've got a problem with this one here. It's not. This is the CPU on the Alice. It's not scanning properly, which is what's causing the problem. So let's, I'll hook up a analyzer to the MC-10, which I think is supposed to be working. I think the guy sent a screenshot. And just see what it's doing for the keyboard scanning. Okay, we're all set up. So again, we've got port 1 on the CPU. And I'm recording, so power on. Okay, and as we expect, we're getting pulses on all of the ports. So yep, staggered. So that all kind of makes sense. So KR0 to KR7. Yep. So I think that's, yeah, for that one there, isn't it? Which one is it? Yeah, okay. So this is here. I think this one here goes via the pull-ups. So these are pulled high, whereas this J5 connector here is directly connected to port 1 on the CPU. So that's not what my Alice is doing. All right, don't worry about that. So start this off again. Yeah. Alright, stop it. There we go. Alright, stop capturing. Yeah, okay. Well, let me. I know one of the things you guys suggested is trying it also without the keyboard connected. So I'll put my Alice on here now and compare. Okay, Alice is now hooked up exactly the same, port 1 and ground. So let me just start recording. Screen capture. Start playing. Okay. Try. Stop. Start playing. Alright. Power on. Okay, and we're there. Yeah, we see what we've seen before. So 0, 1, 2 and 3 basically are all low. So it's only the other 4 pins that are actually responding. So swap the CPU out. Because when you look at the schematic, there is a direct connection between these pins and the port and the port on the CPU and the keyboard pins. There's nothing in between. There's the pull up is on the other one. So what do you reckon? Swap the CPU, I think. So Unicorn Electronics in the US, they've got new old stock I can get. I'll have a bit more of a poke around, but I can't really. Let me stop recording here. Stop. There we go. Can't really see what else it could be. Let's power this off. I'll disconnect it and we'll have just a closer look. So if we have a look, so it's these 8 pins here from 13 to 20. So 13, 14, 15, 13, 14, 15, 16. So 13, 14, 13 to 16 are pooled loads. So they all come up to here, to a via, and then they go straight across to the keyboard. So there's nothing in between. So I reckon it's the CPU. I don't know what else there could be. I guess I could just check continuity just to make sure they're not grounded for some reason. But I think I'll need to order some new CPUs from Unicorn. It'll take a couple of weeks. At the same time, I can also order the PCB from PCBWay to do the AV mod on the MC-10. Then I'll be able to do more direct comparison. So 20, 19, 18, 17, 16, 15, 14, 13. So that's one there. No, it's definitely not grounded. 14. No, not grounded. It's only connected to one pin. Can't see anything else. So I reckon, yeah, problem with the CPU. Alright, so a couple of weeks time, hopefully I should have swapped that out and we'll hopefully be able to progress and finally load something. Because actually what I want to do is I want to try the 8K RAM expansion internal, but until I get the keyboard working, I want to be able to get the keyboard, print out the memory that it starts with, and then print out the memory after the upgrade. So yeah, okay, thanks for persevering, thanks for hanging around, sticking around. I really do appreciate it, and thanks for all your comments as well. I do appreciate it. Just be gentle, be nice. Anyway, thanks. Time to work on something else.